Hello, welcome to my third video. In this video, I'm going to be teaching you about another challenge. The third challenge is called Kadane's algorithm. So in this video, I'm going to explain to you what Kadane's algorithm is, and then after, I'll give you a chance to try it, and then I will solve it for you in C++. Okay, so what's Kadane's algorithm? So it says, given an array R of n integers, find a contiguous sub-array with maximum sum. So if this is your array, they are saying find the array, a part of this array, like a smaller array. It could be like just the 3 numbers, or it could be just these ones. And they're saying find the array which has maximum sum, so that if you add up all the elements in the array, you get the highest number possible. So for example, here the maximum sum is -7, -4, 10, 8. So right now the maximum sum is 8, but if I take out -2, the maximum sum is now 10. Let me put it back. If I take out these 2, the maximum sum is now 6. So 6 is a smaller sum. So we have to find the array with maximum sum. So I could take out this -9 and take out this -2 as well. So here the maximum sum is 14. So this is the array with maximum sum. Also, you have to make sure that you don't remove elements from the middle. So you don't take out 3. Okay, you have to take out from the sides. So you can take out these ones and these ones, but don't just take out -9 and -2, because -9 is, to take out -9, you have to first take out 2. So that's what it means by contiguous sub-array. So the elements have to continue being neighbors to one another. So how do we solve this problem? So how do you find this array? So that's the question. Because this one is the solution we are looking for. It is the answer to Kadane's algorithm. So you can try it out, and you can also read more on Kadane's algorithm to understand it. Now I'm going to move ahead to solve it. Okay, so let us first get some 2 functions here. One to print the elements in the array, then another one to find the sum of all the elements in the array. So let us say sum array is going to be, this is a function, it takes in a vector. Okay, so it returns the sum of the elements. So for that we are going to use accumulate. It's defined in numeric. So we accumulate using this vector. So we start from the beginning to the end. So these two are iterators. So it iterates from the beginning to the end, and the starting point is 0. So that's the function we use to find the sum. Then another one to print the elements in the array. It also takes in a vector. Then it's going to print. Okay, we have to loop over. Maybe we first print this one. Okay, then for integer I in pi, we are going to print I, then we are going to put a space, then we are going to print closing brackets. Okay, so those are our 2 functions. Okay, so let me try to run them. So I say print array, and I say out sum array AR, and I run this. So here it has printed the array and it has printed the sum. Okay. So to solve this algorithm, we are going to use the follow. So we are going to find. We are going to go from each element. What we are going to do is that we are going to create all the possible arrays, and then we are going to find their sums. So we are going to find out all the possible arrays you can have from this, and then from each possible array we are going to find its sum, and then we are going to find, and then if the sum is better than the best sum we have at the moment, we are going to update. Okay, so we are going to have something like this: int best sum. For now it's going to be the sum of this array, and we are going to also have a vector best array. So now it's going to be equal to the array. Okay, so I'm going to say for integer, so this is going to be the first index. So remember we are creating sub arrays. So we are going to create this array, then this array, then that array. Now to create these sub arrays we need two things. We need the index, the first index and the last index. Then we create the array using those two things from this array. When we create those two, that array we find its sum, okay, and then we see if it's better than the best sum. Okay? So for index, so this one starts from 0, then we check if index is less than array dot size, okay, then we increase by 1, okay. Then again we need to find the last index, so for int last index, now this one is going to be based on this idx, the current index, so it's going to start from index plus 1, and where is it ending? So this is the condition, sorry, what's that? Last index has to be less than or equal to array dot size. So this index here, 0, 1, 2, 3, 4. So it has to be less than that. That's the last index we can have. Okay, it is going to be 5 now because this is 0, 1, 2, 3, 4. But the last index is going to be the size, which is 5. Okay. So now we are going to also implement this one by one. Okay, so now what happens, we are going to create a sub array, and the sub array is going to be made from the index and the last index. So if the index is maybe 2 and the last index is 3, so we create a sub array using those two. So we do that once array dot begin, then we add idx, so that's the starting point, then array dot begin plus last index. So that is the sub array. We are creating it from this index and last index and basing on the elements in this array. This begin is an iterator, so it will be iterating from this point to that point. Okay. So after creating that array, we are going to say sum. It's going to be sum array sub array. So that is the sum. So I'm going to check if sum is greater than best sum, then we update best sum, and then we update best array. Okay, that's it. So let us check if our algorithm works. So we have to return 314 here in this array. Okay. So let me say cout best array. Oh, sorry. We are going to print array best array. Okay. So let us see if it returns 314 because this is the best array. It gives us a maximum sum of 17. Yeah, 314. So that's our code. So you can take a look at it and try to understand it. And yeah, thanks for watching. You may also want to see the complexity. This is one, another, this is one loop, second loop. Now the second loop, the third loop is here. When we are accumulating here, because here it iterates over the elements and finds the sum. So we are iterating over the elements. So this thing has a complexity of big O n cubed. Okay. So yeah, guys, thanks for watching. That's the solution.